Hey everybody, in this video we are looking at some interval notation and some ordered pairs. They are different. They both use parentheses, but they are in fact different. You have to use context clues, please and thank you. We are going to use the graph to determine the function's domain, range, x-intercepts, y-intercepts, and intervals where that function is increasing, decreasing, and or constant. Let's start off with the domain. The domain is asking us for what x values is this function defined. This arrow implies it goes to the left forever, and over here it implies goes to the right forever. It is otherwise continuous. That means that my domain goes from negative infinity until infinity. My range, I'm looking at my range from the bottom, the lowest, to the top, the highest, and if there's any gaps or breaks. My range is going to go from -2 with a bracket because I'm including -2. Parentheses are reserved for when we are not including something, so I can never reach infinity, so I can't include it. And then I'm going to go up until 2. So my range is my y values that I'm using. So it went from -2 until 2. Oops, like that. All right, after that, the next thing we have is our x-intercepts. We might have more than one. It looks like we just have one. We have no indication of there being any other, and that is the origin 0, 0. That would never be an interval because you can't start and finish at 0 where neither point is included. It makes no sense, but you know, if an ordered pair was like 0,8, that could be an interval, but it could also be an ordered pair. Again, context clues. If your origin is your x-intercept, it obviously has to be a y-intercept as well because the origin is the point that they have in common. You will only ever have one y-intercept if you are dealing with a function. Next, we are asking, when is this increasing? We are increasing from here to here. We are going to describe our interval where it is increasing with parentheses as an open interval. That will go from x value to x value. I'm describing -2 until +2. Again, that is describing x value to x value. I am describing from -2 until 2. That is when this function is increasing. Decreasing, it's just never decreasing. We read a graph from left to right. For it to be decreasing, it would have to be going down like that, and that is just never happening. So there's no solution for that. So maybe we mark it like NA, not available. I don't know. Whatever you want to mark it, no, it's just not. Last but not least, I'm asking, when is this graph constant? Constant means it's neither increasing nor decreasing. So that's what it's doing for the rest of its domain. The only part of its domain where it's increasing is -2 to 2. I will still not include the endpoint, okay? I will still not include the endpoint where I'm starting or finishing there or there. We will use parentheses, which is an acceptable way to write it on the College Board essay AP exam, even though I believe that it will allow you to include them in some scenarios. Now, I'm not going to fit this nicely here, so you know it's going to bother me. So I'm going to write it underneath. So negative infinity until -2 with a parenthesis, union 2 until infinity. Lovely and beautiful, and that's everything. There's another example like this, and then some other function stuff coming along right after. Hope you found this helpful. Hope you got it right on your own and didn't even need me. So if that's the case, go ahead and yay, give thumbs up. If not, hate it, thumbs down, confused, whatever. I will try to add more content like this in the description box, but I probably won't do that right now. But maybe I could add a playlist at it'll be there if you're watching it after June 10th. Whatever, but tonight I might not be able to put it there. But if the thumbnail at the end of the screen might be able to bring you to a playlist on content like this: domain, range, increasing, decreasing, max, min, all that stuff, because I feel like that's a big struggle for people. So yeah, if you need more help, it'll be there. That's it for now. Adios.